Okay, welcome for today's session. If you have not subscribed, make sure that you subscribe so as to get updates when you upload any session in this channel. This is Mwalimu Teofil Academy. So we provide different lessons concerned to different subjects, especially science subjects and mathematics. Now, today I am going to take you through the way to solve different problems concerning with GCF and LCM. Without losing time, let us start. The first question, find the GCF of Roman 1, 5, 12, and 20, Roman 2, 10, 25, and 30. Now, let us see the solution of this question. Question 1, solution A. In part A, Roman 1, you are asked to find the GCF of 5, 12, and 20. Now, the GCF of 5, 12, and 20. To find the GCF of these three numbers, we just do as follows. Now, we have to use the prime factors of these three numbers. How do we do? Let us see. We take 5, 12, 20. You arrange this way. You arrange them this way. Now, you have to start looking across these three numbers by starting with the smallest prime number, which is 2. You may pass across the three numbers. If there is any which is divisible by 2, you may start with 2. So as we see, 12 and 20 are divisible by 2. So we start by dividing the three numbers by 2. 5 over 2 is not divisible completely. When you divide it, it becomes with a remainder. So if it is not divisible completely, you write it as it is. So it becomes 5. 12 over 2, you get 6. 20 over 2, you get 10. Now, you plot another line here. Here you have again to pass across the three numbers. If there is any which is still divisible by 2, you may write 2. So, as we see, 6 and 10 are divisible by 2 completely. So, you write again 2. 5 over 2, it is not divisible completely. It means that when you divide it, it becomes with a remainder. So, you write it as it is. 6 over 2. 6 over 2, you get 3. 10 over 2. 10 over 2, you get 5. Again, we have three numbers, 5, 3, and 5 again. So, is still 2 dividing in any of these three numbers? The answer is no. So, what do? We shift it to 3. Now, just pass through the three numbers. Is there anyone which is divisible by 3? Yes, we have 3 here. So, we write 3. We write 3. 5 of 3. It is, when you divide it, it means that it is not divisible without a remainder. So you write again 5 as it is. 3 over 3, you get 1. 5 over 3, again it is 5 because it becomes with the remainder. Now, let us see again the three numbers which we have. We have 5, 1, and 5. So here, you may pass across again. May we use 3? No, we can't divide by 3 because there is no any number which is divisible by 3 completely. By 5, yes. By 5 is possible because we have 5 which is divisible by 5 completely. So 5 over 5, 5 over 5 we get 1. 1 over 5 we write 1. As I've told you that if the number is not divisible completely without a remainder, you write it as it is. So we write 1. 5 over 5, we get 1. When you get 1, 1, 1, to me that we have reached the end of our solution. So To get the GCF, you have to look across all of the prime factors which have been used. If there is any prime factor which has divided all of the given numbers completely, you must take it to be included in those factors which are going to be used to find the GCF. But when we pass across all of the prime factors, there is no any which has divided all of the three numbers completely. For example, the first prime factor 2 has divided only 12 and 20, but it has failed to divide 5. The second prime factor 2, it has failed to divide 5, though it has divided 6 and 10. The third factor 3 has failed to divide 5 and 5, so it has only divided 3. The fourth factor 5 has only divided 5 and 5, so it has failed to divide 1. So there is no n. There is no any prime factor which has divided all the three numbers. Now, when it becomes this way, we say that the GCF is equal to 1. You write that GCF is equal to 1. So the answer is 1. The answer here is 1. So the GCF, it means that the GCF of 5, 12, and 20 is equal to 1. Let us see Roman 2. Roman 2, you are asked to find the GCF for 10, 25, and 30. The solution is the same. So here, the way we proceed, you have created the solution. We have the GCF is to solve the GCF of 10, 25, 10, 25, and 30, and 30. So yeah, the way we go, you have to use the prime factors as I have told you before in the first solution. So here we are going to arrange them as follows. We have 10, 25, 10, 25, and 30. Again, you draw these vertical lines. At the same time, horizontal lines is done in question 1, Roman 1. So yeah, you have to start again. Looking the way the different prime numbers can divide these three numbers, and we are going to start by tracing with the smallest prime number, which is 2. Now, if we look across the three numbers, is there any which is divisible by 2? Yes, the answer is yes, because we have 10 and 30. So we have 2 here. 10 over 2, we get 5. 25 over 2, we get 25. As I told you that when the number is not divisible, completely, mean that when you divide it, you get a remainder. Just write it as it is. 30 over 2, we get 15. Now we are through with the 2. Let us see, is there any which is still divisible by 2 among the 3? The answer is no. So here we shifted to 3. Is there any which is divisible by 3? The answer is yes, because we have 15. So by 3. 5 over 3, we get 5. We write 5. As when you divide it, we have a remainder. 25 over 3, it is not divisible completely. It means that you get a remainder, so write it as it is. 15 over 3, you get 5. Is there any which is still divisible by 3? The answer is no. So what do? We just shift it to 5, because the next prime number is 5 after 3. When we take 5, it means that this is divisible, this is divisible, this is divisible. So 5 is possible. 5 over 5, you get 1. 25 over 5, you get 5. 5 over 5, you get 1. So here, this prime number 5 has divided all the three numbers. When you get a number, a prime number which divides all the given numbers, it means that just put any mark so as to make you not forget that number. So I can put a circle here so as to continue remembering this, as it will be involved in finding the GCF. So 5, I have circled 5 so as not forget it, as it has divided all the three numbers. To mean that this will be involved in finding the GCF. But these two, no, because each of them has failed to divide all the three numbers. Okay, after there, we have to pass across the three numbers which we have 1, 5, 1. So here, the prime number which can be used is 5. And when you take 1 over 5, you will get 1, 5 over 5, you get 1, 1 over 5, you write 1. Now, we are through as we are remained with 1, 1, 1. To me, that is the end point. So, the GCF, to get the GCF for this case, the GCF will be, we take the product of the prime numbers which have managed to divide all the given numbers completely. So here only we have 5. So the GCF will be 5. I mean that the GCF of 10, 25, and 30 is 5. If maybe we could have any other prime number which has divided the three numbers completely, maybe just 2, it means that the GCF could be the product of 2 and 5. But because it is only 5, we write it as it is. So the GCF is 5. I hope you have understood the solution for the first question. Now, I welcome you for the next question, which is question number 2. In the question number 2, it states that find the LCM of Roman 1, 5, 12, and 20, Roman 2, 10, 25, and 30. If you look this question, it means that it is the same as the first, but only the difference is that in the first question we were asked to find the GCF, but in the second question we are asked to look for the LCM. So the numbers used are the same, but what is looked for is different. Here is the LCM, but in the first was the GCF. Now let us proceed on the way we calculate the LCM of numbers. The way we calculate the LCM of numbers. Yes, question number 2A. Question number 2A, we are asked to find the LCM of 5, 12, and 20. 5, 12, and 20. Here, the solution, the way we do the solution is the same. We use again the prime factors. So we have 5, 12, and 20. 5, 12, and 20. Again, the smallest prime number which can divide any of the three is 2. 5 over 2, we write 5. 12 over 2, we write 6. 20 over 2, 10. Again, we have 2. 5 over 2, we write 5. 6 over 2, we write 3. 10 over 2, we write 5. We are through with the 2, as there is no n which is divisible by 2 here, so we should be by 3. 5 over 3, we write 5. 3 over 3, we write 1. 5 over 3, we write 5. We are through with the 3, as there is no n which can be which is divisible by 3, so we shift it to 5. 5 over 5, 1. 5 over 5, we write 1. 1 over 5, we write 1. 5 over 5, we write 1. So we have reached the end point. So here we are asking you to solve the LCM of these 3 numbers. In case of the LCM, we multiply all the prime factors which have managed to divide the 3 numbers. So here, the prime factors which we have 2, 2, 3, 5. So the LCM will be the product of the obtained prime factors, which are 2 times 2 times 3 times 5. So here we are going to get 2 times 2, 4. 4 times 2, 4 times 3, 12. 12 times 5, we get 60. So the LCM is equal to 60. The LCM is equal to 60. Again, let us see the solution for Roman 2. For Roman 2, question 2, Roman 2. Question 2, Roman 2, we are asked to find the LCM. The LCM, we are asked to calculate the LCM. The LCM of 10, 25, and 30. Now the LCM of 10, 25, and 30, the solution, the way we do it the same. You have to write 10, 25, and 30 separately, as you can see. Here we plot our vertical lines as usual. Vertical lines, as you can see here. Vertical lines and horizontal lines, horizontal lines. We start as usual with the smallest prime number. If it is possible, it is 2. Now, is there any number which is divisible by 2 among the 3? The answer is yes. We have 10 and 30. So start by 2. 2, 10 over 2, 5, 25 over 2. We write 25 because when you divide it, it becomes with a remainder. So it means that it is not divisible completely. So 25. 30 over 2, 15. Again, we'll pass across the 3 numbers. Is there any which is still divisible by 2? The answer is no, because 15, 25, and 5, there is no any which is divisible by 2. Now we shift to 3. Is there any which is divisible by 3? The answer is yes, 15. So 3, we write 3. 5 over 3, the answer is 5, because it is not divisible without a remainder. 25 over 3. 25 over 3 is 25, because it is not divisible without a remainder. So we write it as it is. 15 over 3, we get 5. After that point, we pass across the 3 numbers. We have 5, 25, and 5. Is there any which is still divisible by 3? The answer is no. So what do? We shift it to look for 5. Is there any which is divisible by 5? The answer is yes. The answer is yes. We have 5, 25, and 5. So by 5, we get 1. 5 over 5, 1, 25 over 5, 5, 5 over 5, 1. So here we have three numbers again, 1, 5, and 1. Is there any which is still divisible by 5? The answer is yes. We have 5 here. So we divide by 5 again. 1 over 5, we write 1 because it is not divisible without a remainder. 5 over 5, we get 1. 1 over 5, we get 1. As I've told you that after remaining with 1, 1, 1 in all columns, it means that we are through with the solution. After there, we have to look again what we are asking for. We are asked to find the LCM. If we are asked to find the LCM, as I told you that when you are asked to find the LCM, you have to multiply all these prime factors which have been used. Now, the LCM for our question will be 2 times 3 times 5 times 5. Here, when you multiply 2 times 3, you get 6. 6 times 5, you get 30. 30 times 5, you get 150. 150. So the LCM will be equal to 150. The LCM will be equal to 150. After there, now we are going to look the solution for the third question. A third question, as you can see it, a third question states that list down all factors of 16 and 24. Hence, find the greatest common factor, which is GCF of 16 and 24. Now, in this question, you are going to use another approach. Here, you are told to list first the factors of 16 and 24, and after listing those factors, you are going to use them to find the greatest common factor, I mean a GCF. So let us see the way we do it. The way we solve it is as follows. Now you can see the way mathematics is easy, but for those who are serious, if you are serious, mathematics is easy. Now let us see. This is a third question. A third question's solution. We are given two numbers, and which is 16 and 24, and we are told to find the GCF for these two numbers. But we are instructed to list first the factors and choose those factors to solve for that GCF. Now let us start. We are asking to find the GCF of 16 and 24. 16 and 24. 16 and 24, but by listing the factors, all of the factors. If you ask me to list all the factors, let us see the factors of 16. The factors of 16. Factors of 16. Factors of 16. You have to note here you are asked to find the factors of 16 and 24 separately. And if you are asked to list all of the factors, it means that you are not restricted only maybe to prime factors, but you are required to list all the factors, regardless they are prime factors or they are not prime factors. So here, the factors of 16 become, we have factors of 16 are, the way we get the factors is as follows. We get the factors as follows. You have to be careful on this way that I'm going to instruct on how we find the factors of a number. Now, we are looking for the factors of 16. Here, you have to start, we have 16. When we divide it by 1, it becomes 16. So, 1 times 16 is equal to 16. Again, when you divide 16 by 2, it means that you get 8. So it means when you take 2 times 8, you get 16. when you divide 16 by 3, it is not divisible completely without a remainder. So 3 is not a factor of 16. 4, it is possible. When you divide it by 4, you get 4. So it means that 4 times 4, you get 16. Have you seen? When you divide by 5, it is not impossible. It is not divisible by 5. When you divide it by 6, it is not divisible. When you divide it by 8, it is divisible. When you divide it by 8, you get times 2. So it means that it will be the repetition, as you can see. If it is the repetition, it means that we have reached the end. So the factors of 16, are 1, 2, 4, 8, and 16. So the factors of 16 are 1, 2, 4, 8, and 16. Now we are through with our factors of 16. The factors of 24. Factors of 24. The factors of 24, the way we do is the same. Now we are dealing with 24. If we are dealing with 24, to get the factors of 24, here we have to start. When we divide 24 by 1, we get 24. 24, we dividing by 1, you get 24. So it means the 1 times 24, you will get 24. Again, when you divide 24 by 2, you get 12. You get 12. So it means that 2 times 12 is equal to 24. When you divide 24 by 3, you get 8. So it means that 3 times 8 will be equal to 24. When you divide 24 by 4, you get 6. So it means that 4 times 6, you get 24. You get 24. When you divide 24 by 5, it is not divisible completely without a remainder, so it is impossible. When you divide 24 by 6, it is divisible completely and you get 4. So it will be 6 times 4, which is the same as this. After starting the repetition, it means that we are through with all the factors of 24. So the factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. So the factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. As you can see, now we are through on the listing of the factors of 16 and 24 as we are instructed in that question 3. So now here, after listing the factors, we are asked to find the GCF, the greatest common factor. The greatest common factor. It means that among the factors of 16 and 24, which is first of all the common factor, and that common factor must be the greatest one. So here the common factors we have 2. It is common to all the two numbers. We have 4. It is common. We have another factor which is common. We have 8. 8 also is common. Another factor which is common, there's no any extra factor. So we have 3 factors, 2, 4, and 8. But the question requires you to find the greatest common factor. So the greatest common factor is 8. So from the two numbers, the factors of the two numbers, the greatest common factor is equal to 8. The greatest common factor of the two numbers is equal to 8. Is equal to 8. So 8 is the answer for this question. Now we are through with our third question. Let us go to the fourth question. The fourth question, we are asked to write each of the numbers 18, 24, and 36 as a product of prime factors, and hence find the greatest common factor. Now we are given these three numbers and we are asked to calculate their greatest common factor, but we are instructed the way to go. The way to show the solution, it means that we have first of all to write each of the three numbers as a product of prime factors. Now, the way we do, let us see the solution for the question number 4. The solution for the question number 4, we are asked to solve the GCF of 18, 24, and 18, 24, and 36. So here, as we are told that we have to use the prime factors, and each number should be expressed as a product of prime factors. Now, how do we do it? Let us start by writing 18 as a product of prime factors. To me, that 18 is a product of prime factors. We're going to write 18. It is 18 here is equal to, as you have to know, when we are told is a product of, it means that 18 should be written as the answer which has been obtained by multiplying a given number of prime factors. Now, 18 is a product of prime factors. You have to trace first of all. 18 is equal to 2 times 2 times 9, as you can see, will be equal to, this 2 is one among the prime factors, but 9 is not a prime factor. So just make 5 as a prime factor. No, just divide these 9 so as to get the smallest numbers which are prime factors. So we are going to take 2 times 3 times 3. Now you can see 2 times 3 times 3. 3 times 3 is 9, but 3 and 3 are prime factors. So 2 prime factor, 3 prime factor, 3 prime factor. So it means that 18 is equal to 2 times 3 times 3. 2 times 3, 6. 6 times 3, 18. So this is the way we write 18 is a product of prime factors. Now let us shift to 24. Let us shift to 24. When we shift to 24, 24 is a product of prime factors. How do we do it? We have 24. So 24 is equal to 2 times 12. 2 times 12. When you take 12 times 2, you get 24. But 12 is not a prime number. So just divide it so as to get the small numbers which are prime, as we are asked in the question. So here we are going to take 2 times 6. You see, 2 times 6 is equal to 12. Now we are made with 6. 6 also is not a prime number. So they just divide it so as to get the small numbers which are prime. Here we're going to get 2 times 2 times 3, times 2 times 3. 2 times 3 is equal to 6, and 2 is a prime, 3 is a prime. So give me that 24 is equal to 2 times 2 times 2 times 3. So it will be 2 times 2 times 2 times 3. As you can see, all of these are prime numbers. Now we are through with the 24. We are through with the 24. After that, we remain with the 36. In case of 36, the way is the same. We have to look for it. 26 will be equal to 2 times 18. 2 times 18. 2 times 18 is equal to 36. But only 2 is a prime number, but 18 is not a prime number. Now, let us make 18 also be a prime number by dividing it into smallest prime numbers, which when are multiplied, we get 18. Now, we are going to have 2 times 9. As you can see, 2 times 9 is equal to 18. But again, 9 is not a prime number. So just divide it so as to get a prime number. 2, it will be equal to 2 times 2 times 3 times 3. Now you can see 3 times 3 is equal to 9, and all of these, each is a prime number. So 2 prime number, 2 prime number, 3 prime number, 3 prime number. 2 times 2 times 3 times 3, we get 36. Now it will be 2 times 2, 2 times 2 times 3 times 3. Now we are through. This is the way we write the given 3 numbers each as the product of prime factors. After that step, now we are in the position of judging which is the GCF for all the 3 numbers by using these prime factors. Which we have obtained. How do we do? Let us see. Now you have to pass across all the given numbers. After passing across all the given numbers, pass across their factors. After passing across their factors, take the factor which is common to all the 3 numbers once. You take it once. So here we have 2, 2, 2. So the GCF, right? The GCF will be equal to, we have 2 as a common in all the 3 numbers. So we write 2. We take it once. Don't take it 2 times 2 times 2. No, as 2 is common to all the 3 numbers, you take only a single 2, as you can see. Now you have to pass across again among the factors of all the 3 numbers. If there is any other factor which is common here, do we have any other 2 which is common? No, we have only 1 2 which is common. We could have maybe a second 2 which is common if we could have another 2 here, as we could have 2 2 2, but we don't have another 2 in the factors of 18. So only we have a single 2 which is common to all the 3 numbers. Just let us look for 3. Here we have 3, here we have 3, and you have 3 here. So it means that even 3 is common to all of the 3 numbers. So we multiply by 3. We don't have any extra 3 which is common because when you pass across the factors of 24, we have only a single 3. So if we have a single 3, it means that we don't have a second 3 which is common to all of the 3 numbers. As if we could have maybe a second 3 here, we could have a second 3 here, 1, a second 3, 1, a second 3, 1. So we could multiply again by 3, but we don't have a second 3 which is common. So here our GCF will be equal to 2 times 3. 2 times 3 is equal to 6. So the GCF, the greatest common factor for the 3 numbers, will be equal to 6. And this will be the answer for question number 4. Now, after question number 4, let us go direct to the solution for the question number 5. Question number 5 states that by listing the multiples of each number, find the lowest common multiple of 3, 4, and 6. Find the lowest common multiple of 4, 3, and 6. Here, the lowest common multiple, its short form is LCM. So you have to start thinking on the way we solved the first question, the second question in the part of LCM. How did we do? So under this section, we are instructed to use the method of listing the multiples. Now, what will be its solution? Let us see. Question number 5. We are asked to calculate the LCM. First of all, write the solution. We are asked to find the LCM of 3, 4, and 6. As you can see. But we are instructed we are recommended to use the method of listing the multiples. Now, what are the multiples of each number? The multiples are the numbers which are obtained when you take a given number and you multiply it 2 times, 3 times, 4 times, and so on. Now, how do we do to get the multiples of 3, 4, and 6? Let us start. The multiples of 3 will be equal to 3. We start with a given number 3. We multiply it by 2, we get 6. When you take 3 times 3, we get 9. In short, you add after each step to get the next number, you add the first number. So here 9 plus 3 we get 12, plus 3 we get 15, plus 3 we get 18, plus 3 you get 21, plus 3 you get 24, plus 3 you get 27, plus 3 you get 30. So here and so on. It means that the multiples of 3 are continuing. So you have 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, and so on. And so on. Here, this is for 3. I have decided to stop after reaching 30, and let us trace the remaining 2 numbers. If the answer will not be obtained among these, we will continue with 33, 36, and whatever. So here we have 4. We have 4 again. The multiples of 4, it means that you have to start with the 4. After starting with the 4, the next one is 4 times 2, we get 8. 4 times 3, we get 12. It means that 8 plus 4, 12 plus 4, 16, 16 plus 4, 20, 20 plus 4, 24, 24 plus 4, 28, 28 plus 4, we get 32. We get 32, and so on, and so on. Also, let us see the multiples for 6. The multiples for 6 will be 6. As I've told you that we start with a given number, so we have 6. After 6 times 2 we get 12. 6 times 3 we get 18. It means that you have to add 6 at each step to get the next number. So we have 18 plus 6, 24. 24 plus 6 we get 30. We get that. 30 plus 6 we get 36. 36 plus 6 we get 42, and so on. As you can see. Now let us back to our question. Our question, we are asked to find the LCM, the lowest common multiple of 3, 4, and 6 by the method of listing the multiples of each number. Now we are through by the step of listing the multiples of each number. So what is meant here is to judge which is the LCM, the lowest common multiple. It means that the lowest common multiple, we have to pass across the multiples of all the 3 numbers, and you have to look for which is the smallest, is the lowest common multiple. It means that the smallest number among all the factors of the 3 numbers. So here we have the common one which is lowest, the common one which is lowest, the common one which is lowest. Here we have 12, and here we have 12, and here we have 12. So if we pass across the factors, the multiples of all the 3 numbers, we have almost 12. 12 is the smallest. 12 is the smallest. You can have maybe other common multiples, but which are greater. So those will be the answer for our question. Our question asks to find the lowest common multiple. So the number which is the smallest, the multiple which is smallest and common to all of the given numbers. We are given three numbers, 3, 4, and 6, which is the lowest common multiple. The lowest common multiple here is 12 because 12 has appeared in here in number 3. 12 also has appeared here, and 12 has appeared here in number 6. So it means that the lowest common multiple will be 2. No, the lowest common multiple will be 12. So the lowest LCM common multiple will be equal to 12. Will be equal to 12, as you can see, and this will be the solution. This will be the solution for question number 5. For question number 5. We are through with the 5 questions. Now, let us go to the next question, which is question number 6. In the question number 6, as you can see, in question number 6, you are asked to find the product of the GCF and LCM of 4, 8, and 12. To find the product of the GCF and LCM of 4, 8, and 12. Now, how do we do it? How are we going to solve it? Let us see. Question number 6, solution. To find the product of 4, 8, 4, 8, and 12. And 12. 4, 8, and 12. Product of, no, it is the product of LCM, and GCF, and GCF of 4, 8, and 12. It means that in this question, you are told to find the LCM and the GCF of these 3 numbers. After obtaining that each value, you have to multiply so as to get the product. Now, how do we go? Let us see. We have, as I told you in the previous questions, so we are going to proceed the same. Here we have 4, here we have 4, 8, 12, 4, 8, 12. Let us use the same method as the previous one. Here, just we go. As you can see, now we are going to use the prime factors as usual, as the simplest method. So here, when you start with the 2, 4 over 2, we get 2, 8 over 2, we get 4, 12 over 2, we get 6. When we divide again by 2, 2 over 2, we get 1, 4 over 2, we get 2, 6 over 2, we get 3. When we divide again by 2, we get 1, 2 over 2, we get 1, 3 over 2, we get 3. As I told you that, as 3 is not divisible by 2 completing without remainder, I write it as it is. We are through with the 2, so now let us shift it to 3. 1 over 3, we write 1. We write 1 it is not divisible completely without remainder. 1 over 3, we write 1. 3 over 3, we write 1. As 3 over 3 is 1, I think you know. Here, we are through with the possible prime factors which can divide the 3 numbers. Now, what is the next step? The next step here is to use these factors to find the GCF and LCM. To find the GCF and LCM. First of all, before forgetting, as I told you that to deduce the factors which are used to find the GCF, you have to circle them or to put any marker so as to allow you not forgetting them when you are looking or you are solving for the GCF. Here we have to circle these 2 because it is divided all of the 3 numbers, 4, 8, and 12. Also, we have to circle these 2 because it has been capable to divide 2, 4, and 6 without a remainder. But this is not circled because it has failed to divide 1 and 3. This is not circled because it has failed to divide 1 and 1. Also, so these 2 are not circled. So the prime factors which are going to be involved in solving the GCF will be these 2. So it means that the GCF for our numbers will be 2 times 2, which is 4. So the GCF is 4. What about the LCM? As I've told you that LCM, we multiply. We take the product of all the prime factors which have been used. So under the LCM, we don't leave any prime factor. So the LCM is 2 times 2 times 2 times 3. 2 times 2 times 2 times 3. So here we are going to get 2 times 2, 4. 4 times 2, 8. 8 times 3, 24. So the LCM of 24, the GCF is 4. But what here we are asking to find the product of LCM and GCF. So the product of LCM and GCF will be equal to 4 times 24, which will be equal to I think it will be 96. So the product will be of the GCF and LCM for 4, 8, and 12 will be 96. 96, as you can see. 96 will be the answer. Now, after question number 6, let us shift to the next question. The next question is question number 7, as you can see on the blackboard. I hope you are still enjoying the lesson. As I told you that mathematics is easy, but for those people who are serious, and one secret to succeed in mathematics is to make solving every day. You have to solve every day. So after saying that, it means that it shows that mathematics needs serious people, and those who are devoted to do it. But if you're not serious, mathematics will be seen to be hard, but it is very, very, very simple subject. And now let us shift to the 7th question solution. The solution for the 7th question, as you can see, it is stated that find the product of the LCM and GCF of 13, 52, and 104. Now we are asked to find the product of GCF and LCM of 13, 52, and 104. Now you can see the way we do is the same as I told you. We are going to write 13, 52, 104. After there, you plot the vertical and horizontal lines so as to allow the use of prime factors on dividing the given numbers. After there, you will end up by calculating the GCF and LCM by using the obtained prime factors which have managed to divide all the given numbers. Now, how do we do? Let us see. Just you have to look across the 3 numbers. As we are given 3 numbers. Now, is there any, as I told you, that you have to start by tracing the smallest prime factor, which is 2. Is there any which is divisible by 2? If there is no any, we shift it to 3. And if there is no any which is divisible by 3, we shift it to 5. and so on. So here 2 is going to be used because we have 52 and 104. All of these 2 are divisible by 2, but not 13. As there's n which is divisible by 2, so 2 is one among the prime factors which are going to be used. Now 13 over 2, we write 13, as 13 is not divisible by 2 completely without a remainder. Now we are shifting to 52. 52 over 2, we are going to get 26. Now, after 52, we shifted to 104. 104 over 2, we are going to get 52. 52. We are through with the 2. Now let us see. Is there 2 still be used to divide any of the 3 numbers? The answer is yes, because we have 26. 26 and 52 are still divisible by 2. So we write 2 again. 13 over 2, we are going to get 13. After getting 13, why have I written 13? I have written 13 because 13 is not divisible by 2 without a remainder. Now, as I told you before, that if it is not divisible without a remainder, you have to write it as it is. Now we shift it to 26. 26 over 2, when you take 26 over 2, you get 13. Now we take 52. 52 over 2, you are going to get 26. Now you can see you have to pass across the 3 numbers. Is there any which is still divisible by 2? The answer is yes. We have 26 here. So the 2 is still being used. Now 13 over 2, we write 13 as it is not divisible by 2 completely. You have to remember, I have told you that if the number which is divisible is not divisible completely to the device, you have to write as it is, as I have done here. 13 over 2, it means that the same, 13. 26 over 2, you get 13. I think you see. So here, do we still require to use or to divide by 2? The answer is no, because we don't have any which is divisible by 2. 13, 13, 13. No any which is divisible by 2. What about 3? Is there any which is divisible by 3? The answer is no. As you can see, 13, there's no any which is divisible by 3. 5, no. 7, no. So what is the next? The next is 13 as it is. So we divide it by 13. 13 over 13, 1, 1, 1. As 13 has divided all of the 3 numbers, it means that this should be second, as I told you that, or put any mark, even a tick. Maybe I can use a tick instead of second. The matter is to put a mark which will make me not forgetting, as it has divided all of the given numbers, 3 numbers. So here I put a tick so as to continue remembering this, as it will be only involved in solving the GCF. So here we are through. We are through with obtaining the prime factors which are going to be used to find the GCF and LCM. Now let us start with the GCF. The GCF for these 3 numbers will be equal. As I told you that when we are looking for the GCF, we are going to take the product of all the prime factors which have managed to divide all the given numbers without a remainder. As you can see, here we have only 13. 2, 2, 2 have failed because the first 2 has divided only 52 and 104, but it has failed to divide 13. The second 2 has failed to divide 13, but it has only managed to divide 26 and 52. A third 2 has failed to divide 13 and 13, but it has only managed to divide 26. A fourth prime number, which is 13, has managed to divide all of the 3 numbers. So this is one among the prime numbers which should be involved in solving the GCF, as it is single. It is only 13. We don't have any which will be used to multiply it, which will be used to be multiplied by it. So it means that we are going to write 13 as the GCF. Now the GCF for 13, 52 and 104 is 13. After there, we are going to solve for the LCM. The LCM will be, you have to remember, I have told you that when we are solving the LCM, you have to take the product of all the prime factors which have been used. No n. There is no any prime factor which should be left when you're dealing with the LCM. Now, our LCM will be 2 times 2 times 2 times 13. Now, what are we going to get? 2 times 2, we have we have 2 times 2 times 2 times 13. The answer here is 104. The answer is 104. We have 104 is our LCM. Now, what are we asking to find? We are not asking to find the GCF, we are not asking to find the LCM, but what we are asking for is to find the product of the GCF and LCM of 13, 52, and 194. So, the product. Now, the product of LCM and GCF of the given numbers 13, 52, and 104. And 104 will be equal to GCF, which is 13 times 104 is the obtained LCM, which will be equal to we have 13 times 104 times 104. 13 times 104, we have 1,352. 1,352. So this will be the answer. This will be the answer. The product. This will be the product for the LCM and GCF of 13, 52, and 104. As you can see, I hope you have understood well. I hope we have understood you well. For question number 7, the answer is 1,352. 1,352, as you can see. Now, after this question, let us shift to the 8th question. Question number 8 states that find the ratio of GCF to LCM of the given numbers 18, 24, and 48. So we are given 3 numbers, 18, 24, and 48, and we are asked to solve for the GCF and LCM, and after that we are required to find the ratio of GCF to LCM. Now let us see the solution. Number 8. Solution. We have 3 numbers. We are asked to find the ratio of GCF to LCM from the 3 numbers. From the 3 numbers, which are 18, 24, and 48. The same, I am going to use the prime factors as I have been doing in the previous questions. So here I am going to arrange 18, 24, and 48. After there, I'm going to plot the vertical and horizontal lines, and then I will start using the prime factors to get the answer. Now let us start. As I have been telling you, here we have 18, 24, 48. We have to start by tracing the smallest prime factor. The smallest prime factor which can divide any of the 3 numbers or all of them. So here, the smallest one is 2. Is there any of the 3 divisible by 2 completely? Yes, all of them. So we have to start with the 2. 18 over 2 we get 9, 24 over 2 we get 12, 48 over 2 we get 24. Now we are through with 2. Let us see, can we still use 2? The answer will be yes if there is any number which is divisible by 2. So here we have 12 and 24. All the 2 are divisible by 2. So 2 can still be used. So here 9 over 2, we write 9. As I have told you that 9 is not divisible completely by 2 without a remainder. So we write it as it is, 12 over 2. we get 6. 24 over 2, we get 12. After there, we have to look again. Is 2 still divisible by, is 2 still divide any of the 3? Yes, 6 and 12 can be are divisible. So write again 2, 9 over 2, we write 9 as it is not divisible completely without remainder. 6 over 2, we get 3. 12 over 2, we get 6. After there, first of all, before I forget, let us see if there is any prime factor which has divided all the 3 numbers. Here we have 2. 2 has divided 18, 24, and 48. So put a mark so as not to forget it when we reach to the stage of finding the GCF. As you have to remember that the GCF is calculated by taking the product of the prime numbers which have managed to divide all the given numbers. So 2 has managed to divide all the 3. What about this? This has not managed to divide all the 3 numbers as it has failed to divide 9. So it has only succeeded to divide 12 and 24. So this is not included. What about this 2? Also, this is failed to divide 9. So it is not included in the prime numbers to solve the GCF. Here, let us continue. What about 2? 2 again can be used because we have 6 which is divisible by 2 completely. So when we take 9 over 2, we get 9. As I've told you that 9 is not divisible by 2 completely without a remainder. 3 over 2, also we write 3 as it is not divisible by 2 completely. 6 over 2, we get 3. Now, we are through with the 2. We can't use 2 again because there is no any number which is divisible by 2 among the 3 present numbers which we have 3, 3, 9. So here we have to shift it to 3. Just we have to pass across the 3 numbers. If there is any which is divisible by 3, we put 3. Yes, all of them 9, 3, 3 all are divisible by 3, so we put 3 here. 9 over 3, we get 3. 3 over 3, we get 1. 3 over 3, we get 1. So this again should be marked as it has divided all of the 3 numbers. Now we shift again. Is still 3 used? Yes, 3 can be used because we have any of the 3 which is divisible by 3, which is 3. So here, when we divide, we get 3. We take 3 over 3, we get 1. 1 over 3, we get 1. 1 over 3, 1. So as we are made with 1, 1, 1, it means that you have reached the end point. So here, what follows is to find the GCF and LCM. Let us start with our GCF. Our GCF, as I told you, our GCF will take the product of those prime factors which have managed to divide all the given numbers completely. So we have 2 and 3. So the GCF will be 2 times 3, which will be equal to 6. What about the LCM? I have told you that in case of LCM, we take the product of all the prime factors which have divided these numbers, regardless each particular prime factor has divided all of the 3 numbers. Now the LCM will be equal to 2 times 2 times 2 times 2 times 3 times 3. So it will be 2 times 2 times 2, 1, 2, 3, 4. There are 4 2's. 2 times 3 times 3. Now it will be equal to. We have 2 times 2 times 2 times 2, 4 times 3 times 3. The answer is 144. 144. There, after that, what next? What next is to find the ratio as we are asked in the question. The ratio we have to find the ratio of we are asking the ratio of GCF to LCM. GCF to LCM. Now it will be equal to GCF we have 6 ratio 144. Let us see if it can be simplified. Let us see if it will be simplified. Yes. When you divide by 60, you get 1. When you divide 144 over 60, you get 24. 24. You get 24. So the ratio of GCF to LCM is 1:24. 1:24. So GCF ratio LCM is equal to 1:24. This will be the answer for question number 8. The answer for question number 8. Now let us see the solution for the question number 9. Question number 9. Question number 9 states that find the quotient between the GCF and the LCM of 35, 420, and 245 by taking the GCF as a divisor. Now you can see, first of all, you are asking you to find the GCF and LCM. After getting them, you have to obtain the quotient by taking the GCF as a divisor. Now let us start by finding the GCF and LCM. Solution: the GCF and LCM of, we have 35, 245, and 420. Now, how are we going to obtain the GCF and the LCM? As usual, we have 35, 245, 420. After there, you have to put your vertical and horizontal lines, as I have been doing here, as usual. As you can see, just use your ruler. As using a ruler, we make your work to be smart and to look nicely, attractive. As you can see what I'm doing here, my work is so attractive. So then just to do as I do, so as to make a clear work. Now let us start by starting with a possible smallest prime number that can divide any of the given numbers. I find 2. 35 over 2, it is not divisible completely without a remainder, so you write it as it is. 245 over 2, you write it as it is not divisible completely without a remainder. 420 over 2, you get 210. 210, you get 210. Again, just you have to look, can 2 still be used? Yes, you can use 2 because 210 is still divisible completely. So 235 as it is not divisible completely, so it is 245. We write it as it is not divisible completely by 2. Yes, now we have 210. When we divide 210 by 2, how much do we get? You get 1. We get 1. 10 over 2. Here we have 210. Just read 210 over 2. We get 105. 105. So here we may just look across the 3 numbers. Do we have any which is still divisible by 2? The answer here is no. There is no n which is divisible by 2, either 35, 245, or 104. No n which is divisible by 2. Now just trace by 3. Let us trace by 3 if there is no n which is divisible completely by 3. For example, 245 over 3, it is not divisible completely without a remainder. 105 over 3, Yes, it is divisible. So this is divisible. So if there is any, we can write 3 here. 35 over 3, it is not divisible completely, so write it as it is. 245 divided by 3, it is not divisible by 3 completely without element. 105 over 3, you get 35. 35. Now you may see, now we have 35, 245. And now, is there any which is still divisible by 3? The answer is no. What about by 5? Is there any which is divisible by 5? Yes, the answer is almost all of them. For example, when you trace 245 over 5, we get 49. Now, all of them are divisible by 5. 35 over 5, we get 7. 245 over 5, we get 49. 35 over 5, we get 7. Now we may see this 5 has managed to divide all of the 3 numbers. So this should be marked as it will be involved in solving the GCF. But these are not marked as, and there is no n which has managed to divide all of the 3 numbers together at the same time. Now let us find another prime number which can divide any of the 3 or all of them. If we look 5 cannot be repeated here because there is no any which is divisible by 5 completely. What about 7? Yes, 7 can be used. 7 may be used because all of them are divisible by 7. 7 over 7 we get 1. 49 over 7 you get 7. 7 over 7, 7 over 7 you get 1. Now we have to circle this 7 as it is dividing all of the 3 numbers. What is remained here? The only prime factors which can be used here is 7. Is 7. Now 1 over 7, you get 1. 7 over 7, you get 1. 1 over 7, you write 1. There, after getting 1 at the end point, that marks the end of dividing. After there, we have to calculate for the GCF and LCM. By starting with the GCF. Our GCF will be equal to, we take the product of the prime factors which have managed to divide all the 3 numbers together. So here the factors to be taken are 5 and 7. So the product will give us 35. 35 will be our GCF. 35 will be our GCF. Now let us look for the LCM, for the lowest common multiple. The lowest common multiple, as I have been doing, as I have told you, that for the lowest common multiple, you have to take the product of all the prime factors which have managed to divide all the 3 numbers, regardless those factors, any of them has divided all of the 3 numbers. We don't see that. We don't look in that criteria. Only we take the product of all as have appeared. We have 2, 2, 3, 5, 7, 7. So here the LCM will be 2 times 2 times 3 times 5 times 7 times 7 times 7 times 7. As you can see, now here we are going to get, we have 2 times 2 times 3, 2 times 2 times 3 times 5 times 5 times 7 times 7. The answer becomes 2,940. 2,940. As you can see, this is the LCM for the 3 numbers. After obtaining the LCM, now let us go back to the question. What is asking the question to find the quotient between the GCF and LCM, and take the GCF as a device. Take the GCF, this GCF as a device. When you are asked to find the quotient, it means that the quotient simply, when you take, you have to note, when you take A over B is equal to C. Here, the number which is divided, is known as a dividend. And the number which divides, I mean that the numerator is a dividend and the denominator is a divisor. The denominator is a divisor. So the number which divides another number is known as a divisor, and the number to be divided is known as a dividend. While the answer which is obtained after division is known as a quotient. A quotient. It is written as a quotient, which is spelled as quotient. A quotient. So quotient is the answer obtained after division, and during division the numerator is known as a dividend, which is the number to be divided, while the number which divides the numerator, the denominator, is known as a divisor, and the answer is a quotient. So there, if we are told that the GCF should be a divisor, it means that the LCM will be a dividend. The LCM will be a dividend. So the quotient, our quotient will be equal to LCM over GCF. As we are told that GCF should be the divisor, so it should be the denominator, while the numerator will be the LCM. So the LCM is to be divided by the GCF. Here it will be equal to 2,940 over GCF, which is 35. Now the answer will be equal to. When you take that, what will be the answer? When you take 2,940 over 35, 2,940 over 5, 2,940 over 35, not 5, over 35. The answer is 84. The answer is 84, is equal to 84. The answer is 84. You have to remember this is question 9. So question 9 is equal to 84. This will be the answer. This will be the answer for this question. Now, after question 9, let us go to question number 10. Question number 10 states that find the quotient of LCM and GCF of 96 and 48 by taking LCM as a dividend. Yes, question number 10 solution. Again, you are asking to find the LCM and the GCF of 96 and 48, but after obtaining those two values, you have to find the quotient. And if you find the quotient, how are you going to find the quotient? The LCM should be taken as a dividend. Now, let us find the LCM. First of all, the quotient. To find the quotient, you have to find the quotient. The quotient. To find the quotient of LCM and GCF of 48 and 96. When by taking LCM as a dividend, Here we go the same way. We have 48 and 96. 48 and 96. If we have 48 and 96, we are going to proceed. As you can see, just proceed as you see what I'm doing here. Use your vertical and horizontal line as usual. Draw them nicely by using your ruler. I recommend to use a ruler because we make your drawings to be seen clearly, especially lines. and your work will be neat, as you see mine. Now, after there, just look for the smallest prime number possible, smallest prime number to divide the two numbers or one of them. Here, the smallest possible prime number is 2. 48 over 2, we get 24. We get 24. 96 over 2, we get 4. We get 4. 8. We get almost 48. We get 48. Again, this 2 has managed to divide all of the two numbers, so it should be marked. Maybe let me use this symbol, maybe star. Let me use this symbol. So as the aim of putting a mark is to make sure that I don't forget to include the particular prime number when I will be solving for the GCF. Now, let us again look across the two numbers. Is there any which is still divisible by 2? The answer is yes, all of them. 2 by 2, 1, 12. 42 over 2, we get 2, 4, 24. There also, let me put a star for this 2 because it has managed to divide all of the 2, so it will be included in solving the GCF. Now let us see, is there any which is still divisible by 2? The answer is yes, by 2. By 2 we have 60, 12 over 2 we get 60, 24 over 2 we get 12. We get 12. So 2 has managed to divide all the two numbers. Again, put a star as a mark for those all which will be included in solving the GCF. Now let us again see, is there any which is divisible by 2? Yes, all of them. By 2 we get 3, 6 over 2, 3, 12 over 2 we get 6. Again, this 2 has divided all of the two numbers, so we put a mark as it will be included in solving the GCF. Yes. Now, is there any which is still divisible by 2? The answer is yes. 6 is divisible by 2, so use 2 here. 2, 3 over 2, it is impossible. It can't be divisible. It is not divisible completely without a remainder. So write it as it is, as we have been doing in the previous questions. Here, we are going to take 6 over 2. 6 over 2, we get 3. So this is not, we are not going to put a star here to mark it as it will not be included in those which are suitable to solve for the GCF. Why? Because it is failed to divide all of the two numbers at the same time. As you can see, 3 over 2, we have written 3 as it is not divisible by 2 complete. So it is managed only to divide 6. So this will not be included in those prime factors to be used to solve the GCF. Now let us shift to the possible prime numbers to divide the present numbers. We have present numbers are 3, 3. The only possible prime number here is 3. If it is 3, 3 over 3, 1. 3 over 3, 1. So this 3 has managed to divide all of the 2. So this should be marked so as to be included in solving the GCF. Now let us start. The GCF, our GCF will be equal to, the product of all the prime factors which have managed to divide all the two numbers without a remainder. So here the GCF will be made by taking 2 times 2 times 2. 1, 2, 3, 4 times 2 times 3. Now, as you can see, 2 times 2 times 2 times 2 times 3. Now it will be 2 times 2, 4, 4 times 2, 8, 8 times 2, 8 times 2, 16, 16 times 3. We get 48. We get 48. So 48 will be our GCF. Now let us look for the LCM. The LCM, I have told you that the LCM, you multiply all the appearing prime numbers which have divided the two numbers regardless, without considering any criteria. So just multiply all of them. So the LCM will be 2 times 1, 2, 3, 4, 5. 2 times 2, 5 times 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5 times 3 times 3. Now it will be equal to 2 3 times 2 5 times, you are going to get 32. 32 times 3, 32 times 3, you get 96. So 96 is our LCM. 96 is our LCM. If 96 is our LCM, now what is next? What is next is to do what we are told to do. We are told to find the quotient. How, in which way? By taking the quotient, by taking the LCM as a dividend. By taking the LCM as a dividend. Now, if we are going to take the LCM as a dividend, as I have told you that a dividend, when we take 5 over, maybe when we take 20 over 40, or let us take this way, 40 over 20. When you take 40 over 20, the answer here is 2. Which means that this 2, the answer obtained after dividing, the answer obtained after division is known as a quotient, as I've told you before, a quotient, and the number with the numerator is the number to be divided. The number to be divided is known as a dividend, while the number that divides a dividend is known as a divisor. So the LCM should be a divided. If the LCM should be divided, it means that the LCM should be divided by the GCF. So the quotient here will be equal to LCM over GCF. So it will be equal to LCM with 96 over GCF 48. So the answer will be 2. The answer will be 2. So the quotient will be 2. The quotient will be 2, as you can see. Now, this is the end of our question. This is the solution. This is the answer. And I think you have understood well the solution, as I have performed it clearly, as you can see. Now let us shift it to the next question. Next question is question number 11. Question number 11. Let us start question number 11. Question number 11, a block is cut into equal units of 10 gram, 20 gram, and 35 gram. Use prime factorization method to find the smallest possible mass of the block from which the pieces can be cut. Now, let us think together of this question. What is required in this question? What is required to be calculated? Here, you have to imagine that you have a certain block. A block is a complete thing, but it should be divided. Maybe you have the block. But this block should be divided into different pieces. These different pieces are of different ways. The first possible way is to divide into different pieces, whereby each piece has 10 gram. The second possible way is to divide it into different pieces, whereby each piece has 20 gram. A third possible way is to divide a block into different pieces, whereby each piece has 35 gram. Now you may think, if that is the case, use prime factorization method to find the smallest possible mass of the block from which the pieces can be cut. So it means that a block has a certain size, but you have to divide it into different pieces. So simply, it means the mass of the block should be greater than 35. It should be greater than 35, so as to make us to be possible for us to divide it into different pieces which can have at least 35 gram. As if the block has a mass less than 35, it will not be possible to divide it into different pieces, each with the 35 gram. Now an idea becomes that the block should have the mass which is greater than 35 gram. But what are we asking to solve for? We are asking to calculate the smallest possible mass. The smallest possible mass. So, though the mass of the block should be greater than 35, but it should have different possible ways. It may have different possible ways. So, we are required to calculate only the way which gives us the smallest possible mass. And this is only by calculating the LCM, the lowest common multiple of these three masses, 10 gram, 20 gram, and 35 gram. What method are we instructed? We are instructed to use the method of prime factorization. The method of prime factorization. Now let us start. We are going to use different factors of each mass given. Now let us start solution. Let us use, we have 10 gram, 20 gram, 20 gram, and 35 gram. By using the factors of each, and we are restricted to the prime factors only. Here, let us start with the 10. 10 is written as the product of the following prime factors. 10 is equal to 2 times 5. I think you know, 2 times 5 we get 10. And all of these are prime factors. 20 is written as the product of 2 times, is 2 times 10, and 10 is 2 times 5, so it is 2 times 2 times 5. As you can see, 2 times 2, 4 times 5, we get 20. Also, we have 35. 35 is equal to 2, it is not divisible by 2. 35 is equal to 5 times 7. 5 times 7, we get 35. Now we are through with the prime factors of each of the given masses of the pieces. So here we are going to look for the LCM from these prime factors. What is the LCM from these prime factors? We go this way. The LCM, the lowest common multiple here will be the lowest common multiple. We proceed as follows. To get the lowest common multiple from these prime factors, simply we take the product of all prime factors which have appeared. Regardless, they have appeared in all of the three numbers, or they have appeared in all of the three numbers, or in one number, or two numbers, whatever it appears. When it appears, you must include it. So, which are numbers which have appeared? We have 2, we have 5, 2, we have 5, and we have 2, 5, and 7. Yes, 2 has appeared. Here it has appeared once, but at the first number 2 has appeared once, but in the second number 2 has appeared twice. In the third number there is no 2. So 2 in the first number has appeared in second, but in the second number we have 2 has appeared twice. So we have another 2. 2 times 2. What about 5? 5 has appeared in the first number and in the second number. In the first number, in the second number, once. It has appeared once. So if it has appeared once and in the third number it has appeared once, so we take it once. What about 7? 7 has appeared once, only in the third number. So we include 7 as it is. So the LCM will be equal to 2 times 2 times 5 times 7. So the answer here will be 2 times 2, 4. 4 times 2, 4 times 2, we get 20. 20 times 7, we get 140. We get 140. This is our LCM, and this must be in a gram. This is the gram. So the conclusion will be we are asking to calculate the smallest possible mass of the block. The smallest possible mass of the block will be equal to 140 gram. 140 gram. This is the smallest possible mass of the block. Mass of the block. Also, this is the way we do. Also, apart using this technique of taking the factors as the product of each number, also we could use this way and could give us the same answer. As you may see here, the alternative for that one, by using the prime factors, using the prime factorization, the same by using the prime factorization, we could use the way I have been doing in the previous questions by arranging them as follows. We could arrange alternative. Let us start with the writing alternative. Alternatively, we could do like this. You may start by arranging the numbers with 10, 20, 20, and 35. After arranging the numbers, you draw as usual vertical and horizontal lines as I have been doing. Like this. What matters is to use prime factors as I'm going to use them. The prime factors first to be used here is 2. When you take it 2, 10 times 2, you get 5. 20 over 2, you get 10. 35 over 2 is impossible. So write it as it is. Again here you write 2 as 2, 10 is divisible, so you get 5, 5 over 2 you get 5, 10 over, as it is not divisible completely, that remained, 10 over 2 you get 5, 35 over 2 you write 35, as it is not divisible completely without remainder. Now, after there, the next prime factor to be used is 5. As 2 is, there is no n which is divisible by 2, even if there is no n, so the next is 5. 5 over 5 you get 1, 35 over 5 you get 7. The last to be used is 7. The last prime factor to be used is 7. 1, 1. So here the LCM, as I have told you, the LCM will be equal to, I have told you that the LCM, you take the product of all the prime factors which have been used. So we are going to take 2 times 2 times 2 times 5 times 7. 2 times 2 times 2, 2 times 2 times 5 times 7. So here we're going to get 4 times 5, 20 times 7, you get 140 grams. So the answer is the same. The answer is the same. The smallest possible mass of the block is equal to 140 grams. This is the smallest possible mass of the block. You underline your answer by using a ruler, as you see. So this is the answer for question number 11. After this, let us shift to the question number 12. Let us shift to the question number 12. Question number 12, as you may see, and the question number 12 states that part A states write 56 is a product of prime factors. B. Find the sum of GCF and LCM of 12, 18, and 24. Let us see the solution. Number 12A. Number 12A is to write 56 as a product of prime factors. To write 56, write solution first. To write 56 is a product of prime factors. Is a product of prime factors. Is a product of prime factors. Simply, it will be 56 is equal to, just let us trace 56. 56 will be equal to 2 times 28. 2 times 28. First of all, you have to know the technique here which I use. I start introducing prime factors in terms of multiplying them, so as to get only the prime factors which should be multiplied to get the given number, which is 56. Now I have introduced already 2. So 2 times 28, we get 56. But 28 is not a prime number, so let me break down 28 so as to get the small prime numbers, which when multiplied gives us 56. So it will be equal to times, here when I introduce again 2, it becomes 2 times 14. You may see 14 times 2, you get 28. Again, 14 is not a prime number. So let us break down 14 so as to make it a prime number. So to make it a prime number means that to get the small numbers which are prime numbers, and when multiplied we get 14. So it will be 2 times 2 times 2 times 7. Do you see? 2 times 7. 2 times 7 now is all of these 2 are prime numbers and they give 14. So when you take 2 times 2, 4, 4 times 2, 8, 8 times, when you take 8 times 7, you get 56. Now 56 is a product of prime numbers. It is equal to 2 times 2 times 2 times 7. So it will be equal to 2 times 2 times 2 times 7. So this will be the answer. This will be the answer for question 12, part A. Question 12A. Question 12A. Now let us shift to question 12B. Question 12B. Question 12B, as you see, question 12B. Question 12B states that find the sum of GCF and LCM of 12, 18, and 24. Here we go. The solution. We have 12, 18, and 24. The same, we're going to use the prime factors as I have been doing here. And I am going to use this system of using blocks. As you see, it is the simplest one. Here, we are asking to find the sum of LCM and GCF. The sum of LCM and GCF for these 3 numbers. So here, first of all, is to find the GCF and LCM for these 3 numbers. As you may see, 12, 18, and 24, not 12, and 24. 12, 18, 24. 18, 24. As you may see, now I'm going to use the blocks as I have been doing. As you see, this way. Yes. Now I put the horizontal lines, as you see, this way. Here it shall start by 2, the smallest possible prime factor to divide any of the three. I think all of them are divisible by 2. So here we get 6, here we get 9, here we get 12, as you see. So this should be marked as it will be involved in solving the GCF. Also, let us shift to, again, can 2 still be used? Yes, we should use 2 because we have 6 and 12 are still divisible by 2. So here we are going to get 3, 6, I mean 6 over 2. 9 over 2 is not divisible completely, so we write 9 as it is. 12 over 2, we get 6. This is not marked as it will not be involved in solving the GCF since it is failed to divide all the 3 numbers once. So let us shift. Is 2 still used? Yes, 2 can be used because we have 6 which is divisible. So here 3 over 2, we write 3 as it is not divisible completely. 9 we write as it is, as when we divide it by 2, it is not divisible completely. 6 over 2, we get 3. 6 over 2, we get 3. Now we are through with the 2. We can't use again 2 as 2 cannot divide any of the 3 numbers. So here we shift to 3. 3 is capable to divide all of the 3. So 3 is possible to be used. Now 3 over 3, 1. 9 over 3, 3. 3 over 3, 1. Here 3 should be marked as it has divided all the 3 numbers once. So 3 has divided all the 3 numbers. It should be marked as to be included in solving the GCF. Here, what we remained with only a single factor, which is 3. When we divide each by 3, here we get 1, 1, 1. So we are through, as we remained with 1, 1, 1 in all parts, or in all 3 columns. So here, the GCF will be equal to the product of the prime factors which have managed to divide all the given numbers. We have 2 and 3. So it is 2 times 3. This will be 6. Again, the LCM. The LCM, as I've told you, that we take the product of all the prime factors, regardless they have divided all the 3 numbers or not. So we take 2 times 2 times 1, 2, 3. 2 times 3, 2, 3 times 2 times 2 times 3 times 3. 3 times 3. Now what do we get here? We are taking 2 times 2 times 2. 2 times 2 times 2. 3 times 3. Times 3 times 3 times 3. So what we get? You get 72. We get 72. We get 72, as you can see. As you can see, 72. Now, after getting 72, what are we asking in the question? We are asking you to find the sum. When you are asked to find the sum is the answer obtained when you operate addition between the 2 values. I mean, when I take A plus B and I get C, it means that C is the sum. C is the sum of A and B. So the answer obtained after adding 2 values is what we call the sum. Now, the sum of GCF and LCM, it means that it is the GCF plus LCM. Now it will be equal to 60. It will be equal to 60 plus 72. Now the answer will be 78. Now the sum of GCF and LCM of the sum of GCF and LCM 12, 18 and 24 will be equal to 78. This will be the answer. This will be the answer for this question. Yes, this is the end for today's session. I take this chance to congratulate you and to thank you for your attention. I hope you have understood well what have been solved through these 12 questions, and it is my expectation that now when you come across with different problems concerning with our LCM with GCF, you will be capable to tackle them. Thank you for attending today's session, and I welcome you in the next sessions. But what to remind you, if you have not subscribed our channel, make sure that you subscribe. It is just Mwalitofiri Academy. That is the name of our channel, Mwalitofiri Academy. So via Mwalitofiri Academy, you will be getting different lessons concerning to different subjects. Make sure that you share with your friends the link of the channel or even the name of the channel, Mwalitofiri Academy. After doing so, you will make even others get our lessons in different periods as we are consistent. Thank you. Have a nice moment.